Join.
Yeah, I'll pay you to take my test. Yeah, me too.
Okay, no. All right, here we go.
They give me $50.
First of all, that's not valuing that person very much.
Yeah, it is. They get $50.
All right.
Take that.
I'm not saying it's not a value, I'm just saying it's not enough. Good morning, Cameron. Camden, good morning.
That's a lot of money. You know what? That's a lot of money for us.
Morning.
We all.
All right, here we go. We are ready to rock and or roll. Okay. Today, we have a pile of stuff to get ready to go.
Great.
I know, I'm excited too. All right, so triangle congruence. We're gonna do a bunch of this. Okay, so this worksheet's already done, turned in. This worksheet's already done and turned in. They got all the little help things. Yay! Help thing. Bam! Triangle workday number 4. Due Thursday at 5 a.m.
Great.
There you go.
Wait, what?
3 of them. But, wait a minute. Oh, there's more. Also Thursday at 5 a.m.
Right.
So here we go. And then Monday at 5 a.m. And then, oh, that's the end of the chapter. And so this is due the 14th at 5 a.m.
What day do we get out for Christmas?
18th.
Wait a second.
I thought it was the 20th.
That's coming too soon.
No, it's not me, actually. Yeah, it's not coming soon.
Oh, you're right. It's the 20th. My bad.
I thought
No, wait a
it
minute.
was the
No.
18th.
18th. Sorry, I was looking for a month. 18th. Well, here's the thing. Friday is the 18th. So then Saturday is the 19th, 20th is Sunday, 21st. So technically, if you're a negative Nelly, your break doesn't start until the 21st because you're off Saturday and Sunday anyway. But in Mr. Moore's mind, this is the day to beat right here. Because I'm a glass half full kind of guy. What?
What day do we come back?
Come back. Well, here's the thing.
We do all the week then.
There's the 4th, you have off. You don't do school at all on the 4th because that's a teacher institute day. So some people have to come back. Mr. Moore, he'll be out of town. But that's a separate issue. And then you guys remove until then you come back to 18th. Yeah. Yeah, so that when y'all can't handle staying inside and being wise and you end up getting quarantined after Christmas,
I was literally quarantined for 7 days. Like,
quarantined over Christmas, and that way all y'all can get all those viruses out
no,
before you come back. So,
I was exposed apparently. I was exposed a whole week after.
okay, how does she still make it about her?
Because I'm just like that, Mr. Moore.
I'm gathering. All right, so at any rate, you'll notice, by the way, this is Monday the 14th. We actually still have class days the rest of that week, yeah? Well, the reason this is set to the 14th is because let's say something goes awry in any of these components here, that gives me an extra day or so to like make sure that by the time you go to Christmas, we're done with triangle proofs. Does that make sense?
Well, we even have time to review them.
No.
Oh, gosh.
No, in fact, if you'll remember, in fact, that's a really good question. If you will remember, that's why you have retakes on every test except the last one of the semester, right? Now, if we get to the end and we do have time, I might reconsider an abbreviated retake policy or something. We'll see, okay? But not promising that. Okay. Hi, Victoria. Oh, gotta let Victoria in. Okay. Hi, Victoria.
Hi.
Okay, so we're just going over schedule. You guys can see that in the slideshow. What we're gonna do now, guys, is we are gonna do proofs because all this stuff, why can't people show up at the right time? Okay, so here we go. what we're gonna do is we're gonna do these proofs, kind of we're gonna practice together. But here's the thing. I think what you're gonna find is after we've done all these worksheets, after we've done all this practice, you're gonna be way better at this than you actually think you are. I know, but I actually do think you're gonna be better at this than you think. So let's practice a few of these guys together. Let's go to level 1. All right, here's what we're gonna do. I am not gonna make you write this down. We're not gonna write all this out. What I wanna do is I wanna go through these together because at this point, you should start to be able to kind of pick up steam. You should be able to pick up a little bit of momentum. First things first, what is everybody gonna do first as soon as they read this? What are they looking for? What's the key word? Bisects. As soon as I see bisects, what am I gonna put? It bisects what? Well, it's a good call, but it bisects a what? An angle. So that means BD bisects ABC. So what are you going to tell me to write? This angle and that angle. Do you agree? And you're going to say angle congruent to angle by def of bisect. Because anytime I have a math word over in statements, isn't it going to be basically the next reason? Okay. Next. What are we going to do next? Oh, boom, boom. And, okay, cool. So what can I say now? Well, look at here. What do I got? So I got, oh, wait a minute. Hey, we got to do blah, 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 reflexive, right? Then you're going to say triangle congruent to triangle by what is it? Side angle side. Cool. And then it says BD bisects AC. ADC. How do I get that this bisects that bottom angle? What do I need for that to bisect that angle? I need what? No. Bisects, if BD bisects this, that's what I'm trying to prove. Don't I need to show that this angle equals, yeah, how do I say if this triangle is congruent to that triangle, how come that angle is equal to that angle? Perfect. And then I can say BD bisect blah, blah, blah. By what reason? Since the angles are congruent, how do I know it's bisected? If the angles are congruent, how do I know it's bisected? Because it cuts in half. That is the definition of bisect. There we go. So we did that proof. Let's do another one. Let's do another one. By the way, that was kind of a long proof, wasn't it? Here we go. What's the first thing you're going to tell me? What? Okay, we're going to do the givens. Done. Check, right? So, AD parallel to BC. As soon as you see that, what's your first step? What? Alternate interior angles. So could you say this goes with this by alternate interior angles? Is that true? Okay, what's the next step? What's this step tell us? So what's your next step? Alternate interior, but with the other lines, right? So you're going to say angle is congruent to angle by alternate interior angles. Do you agree? What's next? Somebody tell me the easy one. Bam! Nailed it. Always count on you for easy one. There you go. Okay, so we can say, I'm just messing with you. AC congruent to AC by reflexive. So what? So what? So triangle congruent to triangle by angle side angle. And how do I get this congruent to this? Well, da-da-da by CP, Do you agree? So, what did we do here? Parallel angles. Parallel angles. What else? Vertical? No. Reflexive? Yes. Triangles? Cool. Parts. Done. All right, let's do another one. Here we go. New problem. All right. Looks pretty similar. Okay. So, what do you got? First things first, parallel lines. So if I have parallel lines, what do I have? This here, B, C, A, D. By the way, why am I putting those, like, why am I dotting those? And why could you maybe dot them on your paper? So it helps you because you say, okay, well, what angles am I talking about? Oh, well, it's pretty clearly that and that, isn't it? Okay? So I say angle, congruent to angle, alternate interior angles. Everybody good with that? Then we got BCAD. So this is congruent to this. Does everybody agree? What else do you know? Reflexive. There you go. Always good. Always good. AC, congruent AC. Bireflexive. Okay, so now what?
Side angle side.
Thank you. Side angle side. So what is side angle side? Triangle this to triangle that. Do you agree? And then how do I get these parts? CP, CTC. Do you agree? Cool. All right. We did 3 proofs in how many minutes? 5? I'll give you 5, right? Okay, so we did 3 proofs in 5. Were any of those, they probably would have taken you longer than it took us. But could you have gotten there on these? It does take a while. I'll give you that. All right, so that's level 1. I think you can do that. Let's do one missing step. Holy cow, look at that proof. But wait a minute, what's the only thing you have to do? One missing step. So let's see if you can place the one missing step. First things first, you got to read the whole thing though. Blah, 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 bisects. So then what happens if it bisects? It cuts some stuff in half. So if they bisect each other, do you have this set of sides and that set of sides? Well, that's pretty easy, okay. Then what's true about those? Vertical angles. So do you have a set of sides, and a set of vertical angles? So tell me what the next step is. Some sort of triangle, isn't it? And what triangle goes with those two right there? Somebody yell it out. What's the top triangle's name? Baker. What? B-A-E. All right. B-A-E. What's up, Bay? Okay, so B-A-E. And what else? D-C-E, because she's doing it in the right order. Very good. By what reason did we have? Because we had sides with the angle in the middle, right? Side angle side. Is that good? Are we done? Yeah. Now let's assume you didn't know what this was leading to. Look at this step here. What does that step say? What is guaranteed, other Baker? The step right before CP-CTC. It has to be triangles, because can I use CP-CTC without triangles? No. So whether you worked it from the bottom up or the top down, it's like a maze. You know, have you ever tried to do a maze and you're like, oh, I got stuck, I don't know which way to go. So I went to the end and I worked my way back the other way, right? Same stuff. So save. Okay. Let's do another one. Oh, this one's even easier. Okay, so here we go. We got a triangle. That whole triangle's congruent. So what's true? That part, so that half and that half. Do we agree? I don't like the way it's showing, because technically, wouldn't it be better if like this half were in yellow and this half were in green or something? So you could see the different parts. Okay. Then, do we have these angles are congruent? So I have side, angle, missing piece for side, angle, side. What do I need?
Reflexive.
You betcha. What's reflexive in this? What's reflexive in this triangle? CE. Do we agree? CE, CE by reflexive. Now do I have side, angle, side? Do we agree? I agree. Okay. So how bad is this one, where we're just finding one missing piece? It's not bad? Not bad? Okay. Now, what happens if you get to a really nasty looking one and you're not sure?
Give up.
Yeah, yeah,
Oh.
you give up and you go to the next one. Why?
Because.
You don't want to spend all your time on one you're gonna-
Right, you don't want to spend all your time and get super frustrated just on one specific thing. Wouldn't it be better if I could get like 3 others? Yeah. Now, ideally, would I like you to be able to do every single proof that this ever gives you? Yes, but let's be honest. Is it super important to be able to do every single one, or just good enough to be able to do like 3 out of 4? Pretty good, right? Now, let's do this one. Reorder step. So here's the thing. They give you the whole proof. It's just scrambled up. All right, now, if I gave you this proof, would you be like, skip?
Yeah.
Okay, fine. So, if I gave you this one, would you be like, skip?
No.
Oh.
Yes,
Okay, but if I gave you this one, would you be like,
Nope,
skip?
not reflexive, nope.
Okay, well, how about we try this one? How about we try this one? What is guaranteed to go in the first step? The given. So is this stuff here in the right spot?
Yeah.
Okay, what goes right down here? No,
No, it's.
the proof, doesn't it?
Yeah.
Because, I mean, this has to be the first step at the top. This has to be the last step. Like, those are not even choices, correct?
Yeah.
Now, you're only down to separating 4 of these things, aren't you? Now, what is something else you can tell me?
Siding this, or side has to be before 5.
Side has to be somewhere before CPCTC, correct?
Yeah.
And don't those normally come near the bottom anyway?
Yes.
Okay. And reflexive can kind of go anywhere as long as it's above the triangle, correct? So let's see if this proof makes sense. Let's see if we're good. We got a set of angles, got a set of sides, got a set of angles, no sides. So angles, sides, sides,
Oh.
sides. Ugh. Okay, but how do I get these sides? Well, what is the reason? If triangle sides are opposite congruent angles, which angles would they be? The little ones, correct? Do we have them already? Oh, yeah, so as long as this comes after this, are we good?
Yeah.
Do you think we're okay?
Yeah.
Could I move this step right up here and be fine?
Yes.
Doesn't matter because it's reflexive. Okay. Perfect, let's do a new one. Let's do this one, we can do this one. All right, what's first? Givens, okay, what has to go last? Yeah, the proof has to go last, right? Okay, suggestions, what do you want?
Move the ASA down to 7.
Oh, ASA has to go down before CPCTC, good call. So now, this is already done, these 2 are already done, you only have 3 to figure out, right? But what's true about vertical angles? True, but it can kind of go anywhere I want, right? How come vertical angles can kind of go anywhere I want?
Doesn't matter.
It doesn't matter, right? Because does anything make no, vertical angles are just themselves. So really, all I have to know is, are these 2 in the right order? So here we go. Sides go, those 2 sides would make what? If this is an isosceles triangle, what's true? The 2, yeah, the opposite angles are congruent, right? So if these sides are congruent, where's those angles? Is it those? No. Is it these? So I'd probably move that right up under the given, don't you think? So I got sides go with angles. Does everybody agree? Those angles, well, wait a minute, I got those angles and these angles. Does it make sense that these angles can be subtracted? Okay, so these have to go somewhere after these, don't they? So I think we're probably good here. do you see that as long as you get the top parts and the bottom parts, and then there's a couple parts in the middle, you're basically good, right? Okay, can we do that? All right, let's go do the easiest / hardest. This one. This is one we skipped. This is one we skipped a week and a half, 2 weeks ago. And here's why we skipped it, because you guys weren't very good at proofs yet. Okay? Let's see if you guys can handle it now that you've practiced a little bit. First things first, what are we given? So this and this are the same. Are we good there? Cool. We're trying to prove this goes with this, correct? How do I get from the blue to the red? Going back to Zasky. Look, Zasky, how do I get from 2 shorty sides to 2 big long red sides? What's true about BC? Okay. Is BC in this one and in this one at the same time? Anytime something is in at the same time, what do we call that? Thank you. So, can we say BC congruent to BC by reflexive? So if I take this and add this to it, and I take this and add this to it, what's the reason for being able to say AC is congruent to BD? Well, what did I just do there? Right, didn't I just take this chunk and add them together? This chunk and this chunk and add them together, right? So could I say segment addition? Now, if I went to my list, it wouldn't give me segment addition. It would say congruent segments added to congruent segments are congruent. Does that make sense? This congruent chunk added together. Okay, so we can do that. Let's do another one. You'll notice there was no triangle involved there, was there? Oh, of course. But in this case, do you see a triangle anywhere?
Yes.
Do you see it up in here?
No.
Okay. So what are we trying to do? We're trying to prove that this is parallel to this. Do you agree? Now, it's not parallel yet, is it? What do I know? Actually, okay. You're not supposed to use triangle congruence, but honestly, I'm going to allow it. Why? Could I say, is this angle congruent to that angle?
Yes.
It's given, right? Is this angle congruent to this angle? Is that given? Can I give a Zasky reflexive? And so now what's true about these two triangles? They're congruent, aren't they? What's true about this angle and this angle then? They're the same by CPCTC, which makes this line congruent to this line by, well, if the angles are congruent, alternate interior angles. There you go. Now, guys, that was the hardest way to do this ever. Do you know that this angle and this angle are congruent? Do you know this angle and this angle are congruent? So what's automatically true? What's true about the third angle in a triangle? That's it. Because can we say the third angles have to be congruent? Because the other two are congruent, aren't they? And so if those are congruent, then can Lonnie just say, oh, they're parallel alternate interior? So Lonnie can do it in 2 steps. But does it matter how many steps you take? No. Here we go. What's the first thing you're going to do here? Parallel lines. So if you see parallel lines, what are you going to say? So I'm going to say angle congruent to angle by AIA. Do you agree?
Yes.
What's the next thing?
Parallel lines.
Okay, you had parallel lines, that's how you got the angle, do you agree? You have more parallel lines, so guess what? More angles, do you agree?
Yes.
Lonnie, how come this angle is congruent to that angle? Because the other two are congruent, so it's the third angle theorem. Could you have also said reflexive, triangles, CP.
Yeah, but that's like a lot of extra work when we can just like, you know what?
I know, right?
Yeah, Kylie, we don't have to do this.
So here's the thing though, does it matter which way you go?
No.
No, now, probably the delta math is not gonna let you do the triangle way because it clearly says no triangles. But could we do it otherwise?
Yeah.
Yeah. What's up? All right, here you go. Give up? No.
Yes.
Now,
Yeah.
here's why I'm not gonna give up. Because it actually gives me kind of a lot of stuff, doesn't it? Let's see here, what do we got? We're trying to prove that BE bisects DBC. BE bisects DBC. So what am I really trying to get? I'm trying to get this angle congruent to that angle. Do you think we can do it?
Yeah, no.
All right, well, let's see, what are we given? Parallel lines. So if this is parallel to this, automatically, what do I have?
Alternate interior.
Do you agree? What else do I have automatically? This is one you probably aren't going to think about because AIA, check. AEA, well, I don't have any exterior here, do I? What's the other one? Ooh. Do I have corresponding?
Yes.
What goes with that?
Yeah.
Do we agree?
Yeah.
Now, why do I care about this? If this side is congruent to this side, what's true about that angle and they're congruent? So if these two are actually the same, then what's true about that black and red one?
They're the same.
They're the same. And does that make bisect?
Yes.
Okay. Do you see? There was no way you were doing that previously, was there?
No.
But I think you can handle it now. I do. I think you can handle it now. By the way, how long have we been working on this?
Like 15 minutes.
Okay, it's not a half hour yet. It's about 20 minutes thus far. Because Emily came in at about 22 after, right? So that means we've been working on this about 20 minutes. And in 20 minutes, did we do triangle proofs 1? Reorder the steps. Missing step and short proofs. Okay. Now, will it take you longer to do that than it took us together?
Yeah.
True. Let me help you out. On the triangle proofs, you got to write it all out and draw your picture. Make sense? For the one missing step, all you need to do is write the one missing step. So do you have to draw the picture there? Do you have to write out the big fatty proof? No. So how quick is that one going to be? Okay. Reorder steps. Reorder steps. Unfortunately, you do have to write this whole one out, don't you? But you only have to write it out once you have put it in order. Once you reorder, once you figured it out, that's where you have to do it. And short proofs, sorry, you got to do this, but they are literally called short proofs. All right. Now, you also have similarity, one ed puzzle to do. When is all this due? Thursday, 5 a.m. So 1, 2, 3, I almost want to make it at 4 a.m.
Why?
Because it'll be over.
What's the difference be?
The
1,
numbers.
2, 3, 4.
Oh, I see.
Why did you do it at 5 o'clock instead of like Wednesday at like 11:59? Yeah.
Because what if you're working at 1 a.m.
Yeah. Or
or 12:30?
That's what I
Because
do.
you're like nerd life.
No, I'm not nerd life, it's called.
Procrastinator.
Or hashtag procrastinator life. Okay, then this is due Monday, next Monday, right? Then what am I probably gonna have for next Friday? The practice, and then the test, And then,
Merry Christmas.
We're out.
right, technically you have a week there, but honestly, I think,
What are we gonna do with the week?
well, honestly, I think we're gonna lose a day somewhere in there.
Why? For why?
Because you're gonna get through part of these and be like, those are hard, I don't understand, oh my God, ah." And I'll be like, fine, one
Me.
more day, whatever.
So then our text will be like, then also.
I didn't want to not finish.
I'm just saying. But the goal of being able to get this done is, if we get it done early enough, maybe we can do some retakes, we'll see. So, alternatively, could Mr. Moore start the next chapter and or have Christmas cookies
Like
this time?
Saturday,
There we go.
21st.
All right, so,
It
I
was,
can,
I don't know. It was
Okay,
Friday and-
your homework, boom, boom, 2 slides.
I'll show you it later.
2 slides, get started right now. By the way, anything that's missing, I've got Delta Math updated this morning, I'm headed over to Ed Puzzle here in a minute, okay? Go.
I think you had level 1 on a different slide, and I already did it, and then maybe.
As long as you've done it once, you're good, right?
Okay, I'm not sure where
Okay, well, just look on Delta Math and see if you got it covered. All right. Okay, cool. All right, online kiddos, any questions?
No.
All right, we'll see you guys later.